1.7 notes, parent functions. This is the last one for chapter 1, so let's get right after it. What we should be able to do today is we should be able to identify parent functions from graphs, equations, and then actually when you get to the homework, I'm going to show you how to do it from tables. So you might want to add on there right now from tables as well. All right, so every function belongs to a family of other functions whose graph have similar shapes. Each family has a parent function, though. There may be lots of them in the family, but there's only one parent. Everything else is just a transformation or a version of the other one. So these are the parent functions. So the first one is f of x equals x. So hopefully you know what that looks like. It's basically a line. And I have a little xy table here. Remember, y is the same thing as f of x. Like those, y equals f of x. Always think of it like that. It's easier to graph things when it's just y. So when you make a table, think of it that way. So if you have the equation, y equals x, basically is what this is. All the ordered pairs that satisfy that means the two have to be the same. X has to equal y in all cases. And when you plot that out, the line y equals x is just this line, 45-degree angle, going right up through there. And that's our parent function. So the line y equals x is a parent function. For instance, if I wanted to describe the line f of x equals x plus 4, it's basically the same line, just the plus 4 is going to shift it up 4 units. So it's going to be the same line, but we would say that this is translated, so it would be translated up 4. Now some people might say, well, wait a minute, what about, could it be translated left 4? And I guess it could, but normally we don't say that the lines get translated left and right. We typically just use the up or down. So that's just kind of the standard way of doing it. Now another thing I want you to notice is the x in this equation, you don't really see it, but it has a power of 1. So the big thing I need you to understand for linear functions is that you have a power of 1. That's going to be important later on. So the next one, the quadratic f of x equals x squared, or y equals x squared. If I plug these numbers into the equation, or if I want to use my graphing calculator, a negative 2 times itself, a negative 1 times itself, 0 times itself, 1 times itself, and 2 times itself. When I plug those in, that's what I get. So I have the 0, 0, I have the 1, 1, I have the 2, 4, and then I go negative 1 up 1, negative 2 up 4, and I get what is called a parabola here. And that's the OG, man. That's the parent of all the x squareds, all the quadratics. There's some version of that. Now, some of them are skinnier, some are fatter, some are moved up or down. Some actually flip over and go the other way. So for instance, if you were to have something like y equals negative x squared, you may see that this thing actually jumps down here to the bottom and is an exact mirrored image of the other one. It might do something like that. Come down that way. So there's ways to, everything else is just kind of a version of that. But what I really want you to focus on, what I really need you to understand, is that quadratics always have a power of 2. Okay? Now, the dominating power, the highest power, is always the one that kind of influences the whole equation. So if you encounter something during this course where you see like y equals 4x squared plus 2x minus 3, and you're wondering what that's going to look like, I realize that there's a power of 1 and a power of 2, but it's always this leading one. It's always the biggest one that dominates it and tells it what it's going to look like. So that would be a quadratic equation up above. All right, moving on down, we have the cubic family. So the cubic functions are all x to the third. That would be the biggest term. If I fill in the table, A negative 2 times itself 3 times would be a negative 8. A negative 1, negative 1, negative 1, that's negative 1, 0, 1 to the third, and 2 to the third. And this is a different look. You know, you have 0, 0, 1, 1. Starts off like a quadratic, starts off like a line, but then very quickly, 2, 8 is like way up here off the grid. And then negative 1, 1, and negative 2, 8 is way down here somewhere. And it ends up looking, when you smooth this thing out, it ends up looking like something like that. And those are what cubic functions look like. You can shift them right, you can shift them left, you can flip them over the x-axis. They could be like, you could do some sort of a compression. You know, if you vertically compress it and you shove all of them in, like for instance, like if you were to do like 1/2 x third, if you were to do something like that, you basically shove all the values down and you kind of make it a little bit squattier. So lots of things we could do to this, and you'll see some of those in the problems. So the last one I want to look at, and these are not all the parent functions, but these are just the first 4 that we want to kind of focus on, are the square root functions. So when I'm looking at the square root function here, and I plug values of x in, you're going to notice something kind of weird here. Like when I do this first one, if I plug in the square root of negative 2, your calculator is probably going to say error. It's going to say, hey, there is no number in the world times itself that can be a negative. Like that's impossible. When we learn about imaginary numbers, we'll come up with some that can do that. But right now, you can't do it, so we're going to leave it blank. Same thing with square root of negative 1. Calculator says, nope, can't do it. Square root of 0 is just 0, so we get that point. The square root of 1 is 1, so I got a point here. The square root of 2 is going to be a decimal, and I'll kind of punch this into my calculator here. So square root of 2 is about 1.4. It's about as good as we can estimate here. So a little bit less than half. If we were to extend this table like to something that I know about, like I know what the square root of 4 is, the square root of 4 would just be 2. So I could put that down in the graph, 4, 2, and you end up with this. It's almost like a parabola on its side, but it's just part of it. You know, if I went all the way out there to 9, that would get up to 3. You know, if I went all the way out here to like 16 somewhere, you know, picture this line, keep on going. If I went all the way to 16, we'd finally climb up to 4. So it's a very slow climbing curve that just gradually kind of creeps up there. So anytime you see something like that, that's going to be a square root family. That's going to be the parent function. And you can shift them left, right, up, down, all different types of things with that as well. So you'll see that. So let's get down. So graph each function in the grid provided. Identify the parent function. Describe the transformation. And the graph, TeacherMade will not be able to graph the graph, but it will have the blanks filled in. And there'll probably be drop-down menus there to make it a little bit easier. So what you can do is you could put this into your graphing calculator if you'd like, or you could start setting up a table. Let's use a graphing calculator just because we really haven't done it this lesson yet. So I'm going to open this thing up and I'm going to come over here and let's punch in. So I'm going to go to y equals. I'm going to clear out what's in there. And we want to do parentheses x minus 6 parentheses, and I want to square that. And let's lock it in, and let's graph it and see what it looks like. All right, so it looks like a parabola. My window right now, if you touch window, it looks like my x-axis goes from negative 10 to 10, and my y goes from negative 10 to 10. The x-SCL is just a scale showing that every increment is worth 1. Since our graph, if you look at the graph, it looks like all the action is happening over in the first quadrant. So I could change my window if I wanted to. I could go in my window and I could maybe make it go from 0 to 10. and then maybe I do my y's from 0 to 10, and that would change it to just the first quadrant. So now when I go to graph, I have a little bit different look of things. So you could go right from there and try to graph it, but it might be easier for you to use the table. Go to second table, and I got some nice values here I could use. So it looks like, well, not many negatives are going to come into play because the numbers are really big. I'm going to kind of go over to here where the numbers are smaller. So the first one I can really fit on my grid is, it looks like I have x is 3, y is 9, so that's on there. 4 over 4 up 4, over 5 up 1, over 6, 0, 7 is 1, 8 is 4, and I could go and scroll down, but I kind of know that this parabola is going to be symmetrical, so I can kind of figure out where that last point is. And now we just kind of smooth it out. So this looks a lot like the quadratic up above. So this parent function is definitely quadratic. And the transformation, well, I know what the parent function looked like. The parent function was this one. It kind of went through 1, 1, 2, 4, 3, 9, 0, 0. So it kind of come down like that and then went up like that. So they pretty much look identical. It looks like the new one has just been shifted to the right by 6 units. All right? Shifted right by 6 units. So if we went right by 6, I'm just going to say the transformation, well, it was a translation by a factor of, and that kind of, I guess by the factor of doesn't really make sense in this case, but translation by a factor of 6 units right. And that's where I'm going to, on the homework, there's going to be a drop down because I know there's a lot of different ways. You could have said, you know, right 6 units, 6 right units. You could kind of mix it up. So there'll be drop downs there to kind of have it make a little bit more sense. All right, let's go to the next one. So last example here, f of x equals x to the third plus 1. And I'm going to bring up the graphing calculator, go back here to y equals, clear it out, and we have x to the third power. Make sure to get out of that little, whoop, I want to go back up there, over, over, over. There we go, now I'm down lower, plus 1. Enter. Let's graph it. We might, oh, we're only seeing part of it because of our window. So I'm going to go back to my window, and I'm going to change it from -10 to 10. And I'm going to go back down and change that one, -10 to 10. And now hit graph. Oh, and there we go. Now, maybe let's look at the table. So right now it's looking like a cubic, which I could kind of tell just by that third power it was a cubic. But if we go to our table, that should help me out a little bit. So let's go in here. Let's put these on the graph. And I'm going to put these on the graph. So I have 0, 1. I have 1, 2. I have 2, 9. It looks like we're going to fly off our graph at that point. -1 is 0. And -2 is -7. Way down here. So we're coming up, 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 up. Make our cross. Go on up. So this looks like it's going to be this. It's the cubic because I saw the 3. So parent function is cubic. The transformation, well, the original one goes right here. So the original was kind of like right down there. So I think we were translated by a factor of 1 unit up. All right, hopefully that's enough to help you get rolling on the practice. See you.